We all hear about the dream of green flying, right? But a recent study decided to, well, stress test that dream against cold, hard reality. It asks a really simple but huge question. Are we actually ready for zero-emission planes? Let's dig into what it uncovered.
So let's get right to it. Could your next flight really be emission-free? I mean, it's not science fiction anymore. Researchers took this exact idea and tested it against today's real-world flight schedules. And the results? Well, they show that while the planes themselves might be getting ready, our airports and our systems, that's a whole different story.
So what's all the fuss about? Why this huge push for a revolution in flying? Well, to put it simply, aviation's carbon footprint is big and it's growing fast. The industry is under some serious pressure to decarbonize, and that's going to take way more than just small tweaks. It demands a complete revolution in how we build aircraft.
To put a number on it, here in the EU, aviation is responsible for about 4% of total greenhouse gas emissions. Now you might think, hey, 4% doesn't sound that big, but here's the kicker. It's one of the fastest growing sources of emissions out there, making it a super important target for climate action.
And look, the industry gets it. This is their own Fly Net Zero plan, their roadmap to decarbonize by 2050. What's so interesting here is how they plan to do it. Sure, things like sustainable fuels are part of the mix, but look at that. A massive slice of this pie is a bet on something totally new, revolutionary aircraft technology.
Okay, so what is this new technology? Well, that brings us to the stars of this particular study. To make their analysis real, the researchers focused on two specific next-gen aircraft that are actually in development right now. So let's meet the contenders.
All right, let's break them down. On one side, you've got the Airbus Zero-E turboprop. This is a hybrid hydrogen plane with a pretty decent range of over 1,800 kilometers, and it can carry 100 passengers. Then on the other side, we have the Wright Spirit, an all-electric plane designed for those shorter hops. It's got a 500-kilometer range and also carries 100 people. So you see, we're talking two totally different technologies for different kinds of regional routes.
Now, this is where it gets really interesting. This is the core of the whole study. It's one thing to have these cool new planes on a drawing board, right? But can they actually do the job in the real world? Researchers took the entire flight network of a major German airline to see where, or even if, these new planes could fit in. So this right here, this is the test bed, a real-world, super complex web of flights for a major airline. The goal was to figure out how many of these existing flight paths could be taken over by our new green planes, without causing total chaos for the current schedule.
Okay, so step one was pretty straightforward. The range filter. I mean, it's just common sense, right? With the Wright Spirit's 500-kilometer limit and the Airbus's 1,800-kilometer limit, a whole bunch of routes got cut right away. Any flight longer than what these planes can handle is obviously out of the running.
But of course, it's not just about range. The researchers use this really smart filtering funnel. First, they ask, can it even make the trip? Then, they only looked at the busiest, most regular routes, the ones flown at least 6 days a week. After that, a big one. Can these smaller planes actually handle the number of passengers by just flying more often? And finally, the reality check. Can you cram all those extra flights into a normal 16-hour day at the airport?
So after all that filtering, the study found that, yeah, there are actually a good number of routes these planes could fly. But, and this is a huge but, this is where the perfect plan on paper smacks right into the messy real world. The study found that getting these planes into service isn't just a tech problem. It creates this whole cascade of new problems on the ground.
The industry experts they talked to flagged 4 huge areas where things get complicated. We're talking about the turnaround process, getting the plane ready for its next flight. Then there's maintenance, which is totally new. Flight planning gets trickier. And of course, the big one, cost and just general day-to-day operations. Each one is a massive hurdle.
And this quote from the study really nails it. Think about something as routine as refueling. Hydrogen or electric charging, that's not like pumping kerosene. It takes longer, it might need new equipment, and it could totally throw off that perfectly choreographed 35-minute dance that happens on the tarmac to get a plane ready for its next flight. Okay, let's make this real. Here's a look at a current daily schedule for a popular flight from Munich to Split. It's using a standard jet, like an A320. See how it all fits nicely into the day? Pretty standard stuff.
Now check out what happens when you try to do the same route with the new hydrogen plane. Because it carries fewer people, you have to fly more often to meet the same demand. Look how packed that schedule gets. The whole tempo of the day speeds up, and suddenly there's almost zero room for error. One little delay could cause a huge ripple effect.
So, where does all this leave us? What's the final verdict? Can we actually integrate these green planes?
The study's answer is yes, but with a massive asterisk attached. It really all comes down to one critical factor.
And this right here is the absolute crux of the issue. The whole plan, everything we've talked about, it all hangs by a thread on whether the manufacturers deliver exactly what they promise. Look at this chart. If the plane's real-world range is just 10% less than advertised, boom, the number of routes it can fly just collapses. The margin for error is razor thin.
And that brings us to the ultimate takeaway. The technology for green aviation, it's coming along. On paper, it works. But the real challenge isn't just engineering a new plane. It's re-engineering the entire global system of airports, fuel supply, and operations to support it. So the final question isn't just, can we build the plane? It's, are we ready to build the new world it needs to fly in?